So in this problem, we need to show that tangent of theta over 2 equals the product of square root of 1 plus e over 1 minus e and tangent of phi over 2 wherever cosine theta is given by cosine phi minus e over 1 minus e cosine phi. So let us begin. So here we'll start with the given condition that cosine of angle theta that's equals to cosine of angle phi minus e over 1 minus e times cosine phi. Now we have a standard formula. We know that whenever we have cosine of angle 2a, so that's equals to 1 minus tangent squared a divided by 1 plus tangent squared a. Now if we need the half angle, then cosine of a will be equals to 1 minus tangent squared a over 2 divided by 1 plus tangent squared a over 2. So we're going to use this formula on both the left hand side as well as the right hand side. So cosine theta now can be expressed as 1 minus tangent squared theta over 2 divided by 1 plus tangent squared theta over 2. That will be equals to, now we have cosine phi minus e in the numerator. So we will express cosine phi in terms of the tangent function. So we have 1 minus tangent squared phi over 2 divided by 1 plus tangent squared phi over 2 minus e. Then in the denominator we have 1 minus e multiplied to cosine phi. So cosine phi will be 1 minus tangent squared phi over 2 divided by 1 plus tangent squared phi over 2. Fine. So let's keep the left hand side as it is. We have 1 minus tangent squared theta over 2 divided by 1 plus tangent squared theta over 2. Let's work with the right hand side. What we'll do, we'll simplify this by multiplying both numerator and the denominator with 1 plus tangent squared phi over 2. So we will get 1 minus tangent squared phi over 2 in the first term. That will be minus e times 1 plus tangent squared phi over 2 whole divided by, now we have 1 plus tangent squared phi over 2 minus e multiplied to 1 minus tangent squared phi over 2. Fine. So let's simplify. We get 1 minus tangent squared phi over 2 minus e will be multiplied with 1 plus tangent squared phi over 2. So we have e minus e times tangent squared phi over 2 whole divided by, we have 1 plus tangent squared phi over 2 minus e plus e times tangent squared phi over 2. Fine. So let's do a few more modification in the numerator as well as the denominator of the right hand side. So we'll have 1 minus e. This will be one term. Then we're going to take the negative tangent squared phi as the phi over 2 as the common factor. So that gets multiplied to 1 plus e. Similarly, in the denominator, we have 1 minus e added to, we'll take tangent squared as the tangent squared phi over 2 as the common factor. So that gets multiplied to 1 plus e. Fine. So this will be equals to, now what we'll do, we'll divide both numerator and the denominator with 1 minus e such that we get 1 minus, we have 1 plus e divided by 1 minus e. That will be multiplied to tangent squared phi over 2 whole divided by 1 plus e over 1 minus e multiplied to tangent squared phi over 2. And on the left hand side we have the expression 1 minus tangent squared theta over 2 divided by 1 plus tangent squared theta over 2. Now if we compare both the two sides, here we can immediately say that tangent squared theta over 2 must be equivalent to 1 plus e over 1 minus e times tangent squared phi over 2. Now if we take the square root on both sides, we'll take the positive square root. So tangent theta over 2 must be equals to the square root of 1 plus e over 1 minus e multiplied to tangent of phi over 2. And this is exactly what we needed to show, hence proved. So let's verify quickly. So we have tangent of theta over 2 equals square root of 1 plus e over 1 minus e times tangent of phi over 2, hence proved.